Hi, my name is Fatih Özel, and I'm one of the authors of the review article titled Exposure to Endocrine-Disrupting Chemicals and Implications for Neurodevelopment. The article was published online in Developmental Medicine Child Neurology in February 2023. Here, I will walk you through the article briefly. Human brain development is a complex process which starts in early gestation and continues until adulthood. The endocrine system regulates brain development, and any interference with hormones may impact on neurodevelopment, in the worst case leading to cognitive or other functional impairments. Endocrine-disrupting chemicals, abbreviated as EDCs, is an important example of environmental interference with our hormonal systems. This is the definition of an EDC, an exogenous substance or mixture that alters functions of the endocrine system and consequently causes adverse health effects in an intact organism or its progeny or populations. In this table, we see different examples of EDCs in the left column. Polychlorinated biphenyls, polybrominated diphenyl ethers, per- and polyfluoroalkyl substances, phenols and phthalates are known as EDCs. They are used in the production of food packaging materials, personal care products and cosmetics, cleaning products, consumer goods, flame retardants. In other words, in everyday life products that everyone is using. Thus, we all are exposed to these chemicals on a regular basis through these sources. These chemicals can also cross the placenta and the blood-brain barrier, which means that the developing brain is exposed, where they can interfere with neurodevelopmental processes. Indeed, a number of adverse outcomes linked to impaired neurodevelopment have been described in the context of EDC exposures. You see them listed in this table. And these links have been supported by evidence from both epidemiological and experimental studies. One well-established example of a hormonal axis affected by EDCs is the thyroid axis, depicted in this figure. Thyroid hormones are essential for neurodevelopment, and as we see here, EDCs can interfere with thyroid hormone signaling at different levels. For instance, by acting directly on the endocrine gland, acting on hormone transporters or receptors, or changing the metabolism in hormone-responsive cells. While thyroid hormone disruptive effects are well established, EDCs affect also other hormonal systems with less well-studied impact on the developing brain. To conclude, even though our understanding of the underlying mechanisms is still limited, there is clear evidence to call for more restrictive use of EDCs in order to prevent human exposure during sensitive phases, such as brain development.